Good morning, everyone. Nice to see you all. Welcome to Thursday of week 7 for those joining us live. As Decorators has pointed out in the chat, please remember that the team evaluation is due 10 a.m. today. I extended it an extra day just because I'm sure a bunch of you would forget. No doubt someone's watching this recording right now thinking, oh crap. So, it's all right. Live and learn. We all make mistakes. I make mistakes every day. Don't beat yourself up when you make mistakes. Like you're all very young. You're gonna keep doing it too, for quite a while, probably forever. Just hopefully less over time. So what we're gonna be getting into today is relatively simple. We've got a part today on decorators, which is it's a tricky one because it probably should be a Python lecture. Not that it matters what it's categorized at, but it's like we're teaching you how to use decorators in Python, which is essentially a Python skill we're teaching you, but decorators as a concept is a great design approach. So it's kind of a mix of both. You can take a lot of this and transfer it and learn some things in another language. And then for project iteration 3, we're going to be talking about that probably in the second hour, as well as a few technical tidbits, because there's a few things I want to run you through. This lecture 7.3 today on decorators as part of the design is really quite a it's a very straightforward structurally but maybe a little bit conceptually confusing lecture, and what we will be focusing on is just like going through some examples and kind of learning about Python and how it works first, because there's a few things about Python that are really critical here. So we've talked in week 5 about writing good software and the importance of writing good software. What we're going to be talking about today is a way to do that, which we didn't talk about on Thursday of week 5 or whenever we talked about it. And specifically, it's just going to be decorators. So what decorators are is they're a language capability that allows you to add functionality to a function without altering the function itself. Yeah, so you think about this, it's like, what is decorating? You think about Christmas lights, or, decorating your house with pretty things. It's like you are trying to alter what it looks like or what it does without actually changing the house itself, right? Decorating, that's what decorating is. So we're going to, do a similar thing in Python, except we're not decorating our house, we're decorating a function. Now, before we get into this, a really critical aspect of making sense of this is to understand what we in Python call keyword arguments and non-keyword arguments. So I'm going to go to the lecture notes here. I'm going to pull the latest changes, and we're going to open up text editor, and we'll have a look inside of lecture 7.3. So inside of lecture 7.3 here, you can see we've got all these different files. We've got this first one here. Now, some of you would have come across this just naturally as part of your project. Maybe many of you have, I'm not too sure. But in Python, if I just kind of get rid of these examples here for a second, this is kind of very simple stuff right here. You got a function called foo1. It takes in a ZID name, age, and suburb. It prints those 4 things. You call it, and it's like, okay, this is all within the realm of stuff you knew before the course. One thing that you can try and start to do in Python, though, is to have default arguments or default parameters. So what I can say here is that, if someone doesn't enter an age, I'll actually give them a default property of 18, and if they don't enter a suburb, I'll give it a default property of Marrickville. And now when I run this, if I go inside of 7.3 and I run this Python 3 decorator 1, butchering this example a bit, this still works, right? So you understand functions, and now in Python we have default arguments, which are in pretty much most languages, to be perfectly honest. So that kind of works, and if you don't provide all the non-defaulted ones, it gets a little bit grumpy. It says it's missing. So Python does expect things unless you give it a default. Now, all of these up here are what we call non-keyword arguments in terms of, well, sorry, this is just a function here. And what we have here is the usage of what we call non-keyword arguments. So what that means is that we haven't specified what this is or what this is. Python is determining that based on its ordering. So we're like, hey, Python, here's 4 things. And it's like, oh, what are those 4 things? And you're like, hi, Python, here's 4 things. And it's like, okay, I will just take that. You know, and it just slots them in order into ZID, name, age, and suburb. Izzy says, what does foo mean? I see it in a few areas in programming. Oh, honestly, I don't even think I've properly understood it. Yeah, foo and bar are used a lot for kind of stub code. It's like hello world of function name, the hello world of function names. Though I don't really know what the formal convention is. I'm sure there's something out there like foos for this, but yeah, funny question. Yeah, as Blake says, it doesn't refer to anything. So we all get this default arguments here. It's called non-keyword arguments. One other way we can actually pass things into Python is to actually specify what these arguments are for. And this is actually something very unlike many other programming languages. So instead of saying that this is just an argument, I can actually say that ZID is that. I need to give this one a name. And I can say that name is this, like that. And this will still work. So what you're actually doing here now is you're using what are called keyword arguments because you're actually specifying for the argument what keyword is associated with it here. You can do this for other things too. I could say, you know, age equals 18. And, you know, that would still work. And you might be asking, like, what's the point of this? What's the point of keyword arguments? Well, the main point of keyword arguments is that they're really powerful, A, if you need to visually specify what the data is, and B, it allows you to actually kind of pass things into a function not in order. So I'll give you an example here. In this non-keyword argument example, where I'm calling it without keywords, what happens if I want to, I need to pass in a ZID and a name. What happens if I just want to pass in a suburb, but I want to use the default age? There's no real mechanism to say, like, you know, default or some stuff, and then give it a suburb of, what's the suburb? Botany. Like that. You can't really, you know, like placeholder that. If you do this, it's going to think botany's your age. So it's all very hard to kind of skip things, you know. So when you're dealing with like non-keyword arguments, you kind of need to do things in that order, moving from left to right. And if you want something on the very right, you have to fill in all the other options along the way. With keyword arguments, you can get around this. You can say something like suburb equals botany. And now you'll see that this works. It says 18 and botany because it's defaulted age. Now, obviously here, if age was not defaulted up here, this would also not work because even though the interpreter will figure out what these 3 arguments are for, it's not going to know exactly, like it's still going to expect age. We're going to get an error there. Sometimes like what happens is if you don't actually default a parameter value, it'll refer to these as positional arguments. Positional arguments are, you know, how you could think about non-keyword arguments, like that. The other kind of key thing here is that you can't have a positional or non-keyword argument appear in the parameter list after keyword arguments, keyword parameters. So for instance, if I want to add another parameter here, like say, what's another detail about me? It's like height. You can't just do that and then pass in the height. You know, let me comment out these 2 lines for a second. You can't do that and then pass in like 106 or something. It just won't work. It's like non-default argument follows default argument. So there's a few pieces of terminology being thrown around here. It's like positional, keyword, non-keyword, non-default, all of this kind of stuff. But the way I think about it, which is relatively simple, is that these are all just parameters, right? So what we call fields on the function definition are called parameters. Some of these happen to be default parameters, such as these 2. And then when we call the function, because, you know, this is all to do with like function definition, parameters. When we call the function here, function call, we can either pass in keyword arguments, which might be referred to as positional, and non-keyword. Sorry, I did the other way. We might pass in keyword arguments and non-keyword arguments. So non-keyword arguments mean they don't have a key. They don't have a name. It's just a value. So this one here passed in 4 non-keyword arguments. This one here passed in 2 non-keyword arguments, but because they were default parameters, it filled them automatically. And this one here passed in 3 keyword arguments. And again, because one of the ones that wasn't provided had a default, it's all okay. So if something's not defaulted, if something doesn't have a default parameter value, you always need to provide it. It doesn't matter like whether you do it with keyword or non-keyword, etc. The other cool thing about keyword arguments is because they're keywords, you aren't relying on the ordering of how you're calling this function to actually give it meaning. And what I mean by that is that you can actually swap all of these around. So here I could actually put the suburb at the start. And that'll still work. Because Python doesn't need to figure out where it slots in, because you've told it exactly. You're like, nope, this is the suburb. The height argument failed, Camille's question before, because the way it's part of the language design, right? So this is like when someone wrote the Python language, they said this is a rule in the language, which is that non-default arguments can't follow non-default. They'll call them tons of different things. I like to call them parameters and arguments because I think it helps separate ideas out conceptually, though you will see the two interchanged a lot. This one is basically saying like you can't define a parameter that doesn't have a default value after a default value one, because it creates all these weird scenarios where like it basically makes the defaults irrelevant, is the short story. Because now that you have height here, you have to define height. But to define height, you have to define everything before it. That's kind of the rule. And if you have to define everything before it, what's the point of these being default? Because you're always going to have to explicitly like override them, like that. So that's where we're at there. And with these keyword arguments, the ordering doesn't really matter, which is super useful because we can change things around. And it just makes sense why they can be ordered in any kind of way. Now you might be asking, like what's better? Should I always use keyword arguments? I don't know. I guess so. I mean, I can't really think of a good downside to it. It might be a little bit more verbose. Sometimes you'll often see, like in people's programming, particularly for long functions, they might do something like this. Or without is that going to work? Yeah, they might do something like this. If you have tons of stuff, and in a lot of ways this is a lot easier to read than to see something like this, right? Because with something like this you're like, okay, thanks for all that list, like what are these things? Particularly with Python, which doesn't have types in it like C, this is a much easier way to kind of contextualize what's happening. So there's definitely probably a big pro for using keyword arguments. I wouldn't say I'd say for longer functions you could probably consider it a good code design choice. But yeah, so that's the crux of function arguments, keyword and non-keyword arguments. I got a few examples here. I think they're all just stuff we talked about. I had another function here called foo2, which had everything defaulted, and I was showing how you can kind of do anything with that. The only thing I don't think I showed you here is mixing them, because it is possible. Oh no, I did show you mixing them. It is possible to mix the two. The only thing here again. The only thing here again about this is that while you can mix them, you can't put keyword arguments before non-keyword arguments. And this actually makes a lot of sense because positional arguments follows keyword arguments. So, I might update this slide, but I've referred here as non-keyword arguments. Python interpreter is referring to these as positional arguments. So positional argument, non-keyword. And this makes sense too, because for these non-keyword arguments or positional arguments, Python is using their position, their ordering, to determine where they go. And when you put this in front of it, you kind of throw that out of whack, because Python's like, okay, is this meant to be the first thing now, or is this meant to be the second, because there's something else there? So again, to avoid a confusing language landscape, they say that you can only put positional arguments at the end. And that's why that one works like that. Now, More interestingly, Python has a feature to help generalize this that you probably, again, you might have seen, but you might not be aware of either. And what this feature is a way to capture keyword arguments and just positional non-keyword arguments all together. And what I'm going to refer to keyword arguments as is this KW args, and non-keyword or positional arguments I'll refer to as args. Camille says, so either put default arguments at the end of arguments list or make all arguments keyword arguments but use default value. Yes, is the short answer there. You shouldn't make anything default that doesn't have a default, of course, like a meaningful default. Though, you know, generally you can have a function with nothing defaulted and still use keyword arguments. The notion of parameters being defaulted or not, and whether you're using keyword or non-keyword positional, they're like two totally different concepts. And you know, I've probably mixed them up for some people because I've just talked about them at the same time, but they're two totally different concepts you could teach at different times. So that's probably worth pointing out. Now, in Python, we have if we have a function here called foo, which takes in a ZID and a name, and I want to call that, and I pass in a ZID, and I pass in a name, like this. You know, we know that this works. Python 3 deca2.py, I get that Hayden thing there. What happens though in Python if we pass in extra stuff? Like my last name or another, what's another suburb? Liverpool, right? We do that. Python, even though like if you have 3 parameters, it expects 3 arguments. If you give it 5 arguments and only expects 3 parameters, it will actually just kind of ignore them, so to speak, right? See how this? We're passing extra stuff, but nothing's happening. It's just kind of vanishing into the void. And watch what happens if we give it extra keyword arguments too, like, height equals 106. Now, while these seem like they're vanishing, what Python does in all the scenarios is that even though they seem, that doesn't work. They don't always vanish. Sorry, confused you there. If you don't have this here, this is probably a point worth clarifying. If you don't have this here, it's going to complain that you gave it something it didn't expect. I think, is it just for keyword arguments? Nope, it's for both of them. So like here it's like you gave me something you didn't expect. The scenario that you can get away with this is if you put these 2 extra parameters in your function definition, which is star args and star quargs. Now again, this is not to do with pointers. Don't be alarmed by the stars, the little asterisks. But what this args and quargs value does is this actually captures all of the kind of unnamed keyword non-positional arguments. Sorry. This captures all of the non-keyword positional arguments, basically stuff like Liverpool, and this one captures all of the keyword arguments, and they capture them differently. Args captures it as a list, quargs captures it as a dictionary. This makes sense because what are all these values? They're just a list of items, or it might be a tuple actually. Whereas when you pass in a series of keyword arguments, you're actually passing in a dictionary, right? Because it's a series of key value pairs. So I can actually print these args and quargs out now. So it is a tuple. I should probably call it a tuple. Default and keyword positional / non-keyword. So I was just taking some notes. So you can actually see here that what this means is that Smith and Liverpool, because I didn't capture them with my named parameters, these were actually captured inside this kind of like bucket of args of like what's left over. And you'll see here too, if I actually now explicitly say capture the last name like that, I have to default it because I have default ones before it. If I capture that, you'll actually see it disappears from args and it ends up back up here, even though I'm not doing anything with it. So args quargs are a great way to generally pick up arguments. In fact, I don't even need this ZID and name here, and I could get rid of this print, and I could just do this. And now I've got all these functions here as all these arguments here is like my list, my args, and then my height here is my quargs. Now again, you might be like, oh, this is tempting. Who even needs to like have parameters anymore when I can just say, print quargs height? Well, that's just a bit weird. It just looks weird. It's not really how programmers expect stuff. So, you still want to use function parameters. But what this is good for is when you don't know what's going to get passed in, fundamentally, right? Because if you know what a function is going to take, you want to capture that in the parameter list. If you don't know what a function is going to take, this is where this becomes really useful. Like, have you ever wondered, I mean, this is not how it works specifically, but think about this. Have you ever wondered how printf works again? When you do this in C, and you say like A, B, C, and you're like, what is the printf function? Does it expect 4 parameters, 4 arguments, or 5, or like why is it so variable? You could actually imagine how you could implement a function like printf now. Like if I just put these in like 1, 2, 3, 4. Like think about how printf could work. I make a function called printf. I take in my format string, and then I take in args because they're all ordered. And now I could say, let's print the format string. Let's just have a little experiment here. Let's print the format string %d, %d, %d. Probably don't need, I need to get rid of that end line because, Python adds the end line already. So %d, 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 and then what I might do here is say, well, before I print that out, let's actually, while format string dot contains %d, we want to, or %d, like replace it. I don't know. This is totally off the cuff. Replace %d with 2. I'm just going to replace it with the number 2. String, okay. Oh, it's like, what is it? While %d is in format string. Is that how it works? Oh, it has to be a string. That makes total sense. So what I'm doing is I'm basically just looping through this while %d's exist, and I'm replacing it with that, though I didn't capture that because remember, replace doesn't do it in line. It actually returns the new string because everything in Python's immutable. And it's like, wow, cool. All right, well, I've just done that. And you know what? We actually probably need to keep track of a counter now, because I don't want to replace it with 2. I want to replace it with a particular args element, because we got given 1, 2, 3, 4 args elements. So I might call this one counter here, and then I'll say, counter equals 0, and counter plus equals 1. So each time it goes through that arg stuff. And now we just wrote out, why did that not work? That's interesting. Clearly made a mistake here. If we print args, we get 1, 2, 3, 4. Args counter, where counter 0, but counter should plus equal by 1. So I'm not too sure what's going wrong here. Let's print out counter. And we get 0. Oh, because it replaces them all at the same time. That's obvious. So now we go to the Python library, Python string replace. And string replace. And there's probably an argument here to only replace 1 character of it. Yeah, count equals 1. So Matthew's already beat me to it. You can see here, you replace the old with the new, and then max is an optional parameter that if you don't give it, it replaces all of them, and if you do give it, it only replaces up to that many items, right? Yeah, so, and Waleed's right about that too. So now I could actually say, when I do the replace old with new, and then I'll say max equals 1, and oops, see, this starts to make sense now, right? Max, like replace takes no keyword arguments. That's a keyword argument. It just expects like a non-keyword positional argument. And there you go. We've written a printf function. That was relatively straightforward. We could start, yeah. Like, and this is super variable now. So we could, say like, hello, %d, %d. So this is kind of where this stuff can be really useful because, you don't know what the size of your input is. Now back to the theory here. Someone asked, do args and quargs need to be named what they are? I don't think so. I think you could call this banana. I think it's mainly the star that matters. It's just that args and quads, oh, it's count, sorry, not max. Thank you. Args and quags are basically like just convention. So if you call it banana, you're going to really annoy someone. So even though you could name it something else, you should really stick to args and quags because that's what everyone understands. That's what you understand. When you go read someone else's code now, that's what you're probably going to expect. So we understand this kind of argsy quagsy world, right? And now let's kind of get on to decorators because that's all pretext for understanding decorators. So if I have a look at my third example here, oh, sorry, I meant the fourth example. Skip the third one. That was all part of the same slide. I have two functions here. One is called getFirstName, which returns Hayden. One is called getLastName, which returns Smith. And if I want to make both of these uppercase, right? Like if I get rid of the final code for a second, and I want to make both of these uppercase, you might say, well, it's easy to make them uppercase. Just return upper. You know? Like this. You know, and then you're like, okay, sure, return upper Hayden Smith. Or you might be thinking, well, let's not modify the function because we have a principle here where we don't want to change the function. And you might think, oh, well, let's just do this on the output. So this is a little bit closer to a decorator because you're not changing what the function does. You're just kind of wrapping around it. You're kind of adding more capability on the outside of it. But the problem is this isn't a generalized solution. So what we might prefer to do instead is where this example started, which is to have like a make uppercase function. And what it does is it takes in an input and then it simply returns the uppercase of that input. So it's like just the basic abstraction for the upper function. Now that's a decorator in a nutshell, conceptually, right? Like if you said to someone, I wrote a decorator for this function, they'd be like, that makes sense. Python has some extra abilities that allow us to take this one step further and make it a bit more elegant. But conceptually, this is all we're doing. We're just going to get fancier and fancier with it. We're taking a function with a capability and we're decorating that function. Now, a proper decorator in Python is a little bit more complicated. So let's try and do this with the proper Python way. And the way we go about it's a little bit different as well. In Python, so like, by the way, just to be clear, this is not an exact, like, what I'm about to show you is not like this exact example. It's slightly different. It's just this is like an easy way to kind of just be like we're decorating something. But the way we deal with it in Python is slightly different. I have my getFirstName function and I have my getLastName function. I want to call getFirstName and I want to call getLastName. But in both of those cases, I want to make sure that the output of all getFirstName and all getLastName functions are made uppercase. To do that, I don't add the function here to the actual like call like I did in the previous example. I actually add it to the function definition. And I do that because what I do is above my function, I go at and then I give it another function name. Right? So at means decorator and this is the name of a function to call. And this function here is called make uppercase. So if I get rid of this for a second and I'm like do decorator stuff, this is what we're doing. We just haven't written the decorator yet, right? So we say that, you know, make uppercase is applied to getFirstName and getLastName, and that will ensure that the output of both of those functions, whenever it's called, is always decorated with that kind of ability. Now, what in the world does the make uppercase function actually do in return? This gets into the world of kind of functions returning functions, which I think is a little bit weird. But I just want you to focus, I guess, firstly on, because you'll have to just stare at this for a while. I want you to focus firstly on the code I've highlighted here. What we want to do, and in fact, I can keep this even simpler to start. Let me get rid of this for a second. I think this might really make it a bit clearer because we'll come back to that. This works. What we want to do is when you call getFirstName, what Python actually does is it's not actually calling getFirstName here. It's actually calling the result of passing getFirstName into the make uppercase decorator. So what the make uppercase function does is it actually takes in this entire function. It takes in this as like a function pointer, and it passes it in here, and what the make uppercase function returns is a function. It basically takes your function and replaces it with a function that wraps around your function, right? So your get first name function here is passed in, and you're actually returning this wrapper function, and all the wrapper function does is return your function. In fact, you could make this decorator definitionally useless by doing this. So this would be a decorator that is like the minimum size of a decorator that does nothing. If this helps like kind of hone in on the example, where you take a function and you simply return a wrapper function, and that wrapper function, all it does is call that function. So we are just calling this function without modifying how it works. We're just going to add things to the outside of it, right? It's the same kind of way that, you know, if you had a function here called def1, and this one printed hello, right? You could come along and make a function called to that's just going to, well, you know, let's say it just returns hello. You could make a function to, and all this is going to do is return a new function called, you know, one wrapper. That's just going to return 1. And you return 1 wrapper. Like, that's kind of what we're doing here. We've got this function that's just returning something, doing something. And we're creating a new function whose job it is to provide you a function. So to actually gives you a function. And maybe if I just take this one step further here, because I know this is always a topic where students get confused. If I look at this really simple example here, if I say print 1, this will print hello, as you'd expect. But what I want to do here, more likely, is I actually want to say that, you know, my new 1 is equal to the result of 2, and then I want to print new 1. And this will also print hello. And this is a little bit weird here, because you notice here that new 1 is a function, and this to function is actually returning me a function. So to is a function that I call, and it returns a new function, and I'm capturing that function in a name here. So we're kind of treating functions and variables like the same thing, and most high-level languages can do this. So to is like a function generator, if you will. It's something that we call, and it actually produces a function for us. So to is a function producing function. If I want to now kind of wrap this, it's really simple, because I can just add dot upper here. So when I call to, which is a function generator, it goes and generates this function and returns it to me, and all this function does is actually call that underlying 1 function, but makes the result uppercase, and now I've got myself a decorator. You know, to is a decorator. It decorates your function and wraps it up into a new function. So what we're doing with our decorators up here is exactly the same. We have a function called make uppercase, which returns us a wrapper function. So make uppercase actually just is a function generating function that returns us like a wrapped version of our function we're decorating. And it's like, the main differences you'll notice here are that 1, we're not having to do any of this weird new function equals 2, because Python does this for you. Like, Python will actually say, oh, so instead of calling get first name, you actually want to have a new function that wraps that. Sure, okay, I'll call make uppercase, which I know is a function generator, and it will give me a new function that's going to wrap it. The other key thing is that we actually have this argument here called function, which is the function being passed in, and that's how you can, like, because you could technically get away with this, right? Not having that, but then you have to kind of always call the same function, which defeats the point of a decorator. Because it's like, you don't want this make uppercase to wrap a function, you want it to wrap any function. And the way Python works is that Python will actually pass your function as an argument to the decorator function that's being called. So Python actually passes this into that, and it passes this into that, and that's what function is. I mean, you can actually see that, right? If I print function, you'll actually see this, because this decorator is called twice to decorate both functions, you'll actually see that it says the first time I was called, I was given function get first name. The second time I was called, I was given function get last name. Now, to some questions, Osama, is this equivalent to function pointers in C? I mean, it uses concepts similar to it, yes. Decorators are not function pointers. They use that idea. Gorb says, could you potentially apply a decorator that does something with the input arguments instead of the output of the function? Sort of. Let's explore that. I can't remember quite if I'm understanding that right. Joshua says, why do we need the wrapper inside too? Because we want to modify it. So like I'm gonna have a similar question here. So like this is a decorator that does nothing, right? And Josh asked kind of a valid question, which is like, why can't make uppercase? Like, why do we need this wrapper? If this is just returning a function, why don't we just return the function? That works. That works fine. And the reason is because the second you want to modify something, the second you want to deal with what the output does, you actually want to get the output of this function. So you can't actually really say like return function.upper here, because now this decorator is returning a value. Decorators have to return functions. Decorators are like, they take a function and they give you a new function. And then they say, here's that new function. Go execute it whenever you're ready. So what you'll notice here is like, remember how before I was just printing out this like function thing here? Check this out. If I get rid of the name equals main, this still runs. This is not happening when you call the function. This is happening when the program loads, right? We're not calling get first name, but Python is taking this and it's actually executing it there. So we're not actually interested right now at the time of this running of calling get first name. We don't want to do it. And that's kind of the problem here is that, you know, if you tried to say, oh, we'll just return the function result.upper, it just doesn't make sense because, well, I don't even know what this would do. See, you can see nothing happens here, but this would probably, yeah, now it's just confused because what you've actually said is take in this function and replace it with a string, because that's what it is. Like the decorator, you know, turns a function into a function normally, but you've now turned a function into a string. So now when you actually go to call this, Python's crapping its pants because it's like, string's not callable. Like that's like saying, you know, name equals boo, name. Python's just going to be like, that's not a function. I have no idea what you want me to do with that. So, let's unwind all of this. So we have our wrapper here. And then we do upper. And yeah, I'm getting some great questions in the chat too about like, you know, Jai Shun says, is that what the app is in Flask? Yeah, exactly. That's how Flask takes your function and turns it into an HTTP network capability. That is how with Python fixtures, it takes your function and it adds some stuff around the outside, right? Because what does fixtures do? Fixtures kind of like puts some stuff before your function and then passes it in. But I'm just conscious of time as well. This is a really simple example in Python, and I want to get to the more complex ones. So here, you don't just, like, you can do anything here in your decorator. The examples I sometimes give are like, if you want to double, like, you know, let's make another decorator. Let's not butcher that one. I'll make a decorator called, you know, copy or double output. And all it's going to do is it's going to return the result of function with a space and then the result of the function again. So if I call this one double output and I run this, we've now just written a decorator that takes a function, it returns you a new function, and what that new function does is it calls your original function, calls it again, and puts a space between it. You know, so it's really your chance here to kind of really tweak with things. Now, where this gets, I guess, a bit trickier is that these examples are relatively straightforward because of the fact that our functions themselves don't take in any parameters. So, what happens if this did take in a parameter? What happens if this actually took in like a greeting, right? Where we actually wanted to return greeting, Hayden. So when we call this, we actually want to say something like, good morning. It's a very common thing, right? Often your functions have parameters. So let's have a look what's going to happen here. It's going to complain, and the reason it's going to complain is because your function getFirstName took in one argument. What your decorator returned when it took your getFirstName and returned you a new function is it actually returns you a new function without any parameters, right? So getFirstName had a parameter, wrapper does not. So your wrapper actually needs a parameter here too, such as greeting. So your new function that's replacing your old getFirstName function needs this parameter, and you know what? You're going to have to place it into the function it's wrapping, because everyone expects it. So this is kind of where these functions come from. So now we got good morning Hayden. You can see it's made it all uppercase, which is kind of funny, right? So good morning Hayden, it makes it all uppercase like that. And it's like, well, here's the next problem. You know, what happens if my getLastName has two, you know, parameters, like greeting and salutation. Greeting and, not salutation. Title, I can't remember what it's called. So now we want to say, you know, greeting title Smith, like this. And then my getLastName function here, I was going to pass in goodbye, and then, you know, Mr. Smith, like that. And it's like, all right, well, what's going to go wrong here? Now the decorator is expecting two arguments. So it's like, oh, I need to pass in the title here. Because when make uppercase tries to decorate this, it's like the underlying function expects two parameters. So my wrapper function needs to take those and kind of pass it through. But now the problem is that's just going to break getFirstName, because getFirstName only wants one. So the way around this is actually to use what we did at the start of the lecture with args and quags and say, you know what, we don't actually care what's being passed into the wrapper. We're actually just going to go and capture everything. And then what we're going to do, as you can kind of see on these slides here, is we're just going to pass them straight back in. So I'm just going to pass args and quags here. So it's kind of like a way to pass through all that information so that everything works generally now. Get rid of this. Oh, well, this didn't work for a different reason. Sorry, I missed that. That should have been like that before. It still wouldn't have worked. But so now we have something like this that generalizes it. So it's like the decorator's comfortable passing anything through now. Now the next question sometimes people have is like, okay, this is all well and good, but I notice when I do Flask that sometimes I do things like app.get, and then I say, you know, hello, like this. So what happens if I want to, you know, what happens if I want to pass in an argument here? Such as, let's try this a different way. Let's change our make uppercase to repeat. And instead of making it uppercase, let's actually capture our like output, and let's return output times 3. Right? This will repeat it 3 times. Now this makes sense because in Python you can multiply a string by a value and it repeats it that many times. And now we get good morning Hayden, good morning Hayden, good morning Hayden. Okay, but how do we make this variable? Well, this is I think where decorators can get a little bit confusing too, because with decorators you have all the parameters of the function you're decorating, which tend to be what you leave alone because you're not super interested in, you know, how that function works. So you're just decorating it. But if you actually want to give some parameters or some variability to the decorator itself, such as how many times should it repeat, you could do something like times equals 1. You know, let's say we're doing what happens in Flask. You know, maybe we want to repeat this one twice, and we want to repeat this one 3 times. Now we're actually adding parameters to our decorator. So I might add an argument here, and let's just print it out. Print times. I've clearly forgotten something here. What is this? Type error. Repeat missing one required positional argument function. Oh, I've probably buggered this example up. Sorry, I think it's more complicated than that. Oh, it is a lot more complicated than that. Oh, I think I've gotten some concepts mixed up here. So I don't actually think I had an example for that. I think I intended to not do that. But let's have a quick look. So like Python decorator argument, right? Sorry, I think I just kept jumping too far there. Let's see what's here. Someone might already know because they've tried that. Oh, someone's already got a repeat thing. There you go. Repeat function, repeat 5 times, where's that actual function called? Oh, this gets super confusing super quickly. Yeah, I think I remember why I didn't want to do this actually. I thought about this the other day and was like, we can talk about that. But then I was like, it gets really confusing really quickly. Because you can actually see in these examples here, if I come back here, that this is an example where they're like, okay, here's a function that says something. You know, takes in a message and it says something. I want to repeat that function 5 times. So what they actually do is they actually take your decorator function, and you're all used to this here, right? Where you have like your decorator that takes in a function, and it returns a wrapper function, and that wrapper function just passes the argument straight through, like you'd expect. But what they're saying is that if you actually want to pass in arguments to the decorator, you probably need to wrap it in another function. I'm guessing is what I can see there. So what they're saying is like, all right, well, you have your decorate like this, but now you're actually going to have another function called repeat, which takes in the times. And, you know, we'll see if this does what we expect. This is just a bit of experimentation here. Function is not defined. Yeah, okay, I know. So it gets super weird super quick, because you can see in both of these cases it's been repeating by 3, but that's because I, you know, had the times there. So now this first one repeats 2 and the other one repeats 3 times. So the kind of layers here are that, you know, the first examples we saw with just like the simple decorator function and the wrapper, that's kind of what you normally do. And in many cases in your own code, you're actually probably going to find decorators very useful. The most obvious example that I'm going to naturally throw at you, which all of you should be able to have a stab at, is authentication. You know, like, how do you authorize that a user, you know, can do something? I'm sure in many of your functions at the moment, you know, whether it's like channels or whatever, you have some kind of code up the top that maybe it says like a cert logged in or something, and that simply calls a function, but it gets complicated, right? Because maybe it throws an exception, but it's like, what's even better than having this like kind of line item at the top of everything that's like assert, you know, assert authorized token, is you could actually probably figure out ways to use decorators to simply decorate a particular function that you have with, like, you know, authorized def channels create, you know. So that's probably the main area that I would say that all of you should probably try, at least, to play around with decorators. It's a bit of a confusing concept, but also it's one of these things. So the reason this concept's confusing is because up to this point, for most of you, the notion of treating functions like values isn't something that's been core to your learning, right? So like, I teach 6080 at the moment, where students do a lot of JavaScript, and this is kind of like a fundamental part of JavaScript. And if I showed this to someone who's been doing that for a while, they'd be like, this makes perfect sense. And it makes perfect sense to me too, right? And I'm sure to a number of you, though this is weird because you're returning functions as a value, which are kind of like function pointers, but in C, function pointers and values are different things. In Python, they can all kind of be generalized, you know? Like, I can make a function here called hello that just returns hello. And I can add a value here called hello2, which is hello. And these are both things. Like, I could wrap them up in a tuple, right? I could say my tuple is hello and hello2. And I could print that tuple out. And this, you know, this would give me something. A function and you know, a tuple. So this whole wrapping function thing can get a little bit heady pretty quickly, and that's okay. So, you know, Matthew's made some comments about understanding it. Blake says, how can the wrapper access args and quargs when they're parameters of the function arg rather than parameters of the decorator itself? It's a heady question. How can the wrapper access args? Let me just simplify this example back down, because like the whole decorator argument thing isn't something that I don't think many of you would need that. So that was more just like this is how that might happen. So let me come back to like the simpler example here, where let's just say we're going to double it, you know, and I'll really make this a bit simpler. So whatever it outputs, we're going to double it. I've got this repeat decorator here. Sorry, I'm reading Blake's question again. How can the wrapper access args and quags when they're parameters of the function arg rather than parameters of the decorator itself? Because, yeah, so here's how to think about it. Here's the simplest way to think about it. What a decorator does is it comes along and it says, when you call get first name, you're actually going to be calling wrapper. That's it. You know, and wrapper is a function that just calls the original function you had, just times by 2. That's the job of a decorator. It's to take your function and to wrap it inside of another function, and then that function gets used instead. You know, and many of you will conceptualize this different ways. That's why I think it's a fun topic, and that's why I think playing around with it is the best way to understand it. It's just one of those things where you just got to play around with it and print some values out, and it won't work, and look at some examples, and then like you'll see it. ArtSmart says, do you think we can use args and quags all the time when decorating our functions? Often you can, yeah, because often if you're literally well, you're pretty much always decorating it. You don't know what's going to be passed in, because anything could be passed in, because you could be decorating like anything, arguably. Not quite anything, but it's generalized. That's why we use args and quags. Josh says, can a decorator adjust an argument or add an argument? Yes, it can. Wow, what a great question from Josh. There's so much stuff you can do here. For instance, I could have this return banana, or, you know, banana. So here's the funny thing. It's like now all of my functions could say fruit, could all take in an argument for fruit, and they might all have to print that fruit like this. Darr, what are you doing? What do you mean non-int? Can't multiply sequence. What? It's not a sequence. I'm so confused. Maybe it's trying to multiply the return. I don't understand. That's okay. Let's get rid of the repeat for a sec. What am I doing wrong? Can't multiply sequence by non-int of type tuple. Oh, there's no comma. Freaking hell. Thank you. Yeah, so you can actually see, you can actually add these arguments to it. So you could actually like have something here like fruit. I mean, how do you think, like this is how a lot of decorators work, right? Like how do you think your PyTest fixtures work? They work by taking in an argument in the, you know, the decorator line, processing it, and then giving you the result of it as an argument. So your function actually takes in a parameter that you don't give it when it runs. You know, like, so you can, you know, you can actually manipulate it. There's another concept not being explained well right now. Encapsulation of the function argument to the decorator. Encapsulation of the function argument to the decorator. You have to elaborate on what you mean by that, Matthew. So the last question I kind of want to touch on is ArtSmarts, which he says, which they say is like, do you think we can use args and quags? Oh no, I already answered that one. Sorry, there was a question I saw before. I think Gorb asked a question and then they said they understood it, so I skipped over it. But the question was, to use the decorator and authorize an ID, you would have to take in the ID before the function was called. Here's the question. Can a decorator access the arguments given to a function before the arguments take them in? Basically, can you extract, as part of your decorator logic, this good morning string here? You know, can you access the arguments passed in? This is probably in relation to the project. The answer to that is yes, you can. I'm not going to really go through that in any detail because I think that that's kind of one of the challenges of this. You know, like you're all kind of adults, and we're not here to spoon feed you literally everything. So, what I'd say is it's doable. The kind of way to do that is to add more logic to the wrapper, because in here is where you can access everything passed in to the underlying function, because you have access to args there. So you can do all of this inside the actual wrapper itself. Very rarely are you actually going to have much code here. You know, there's not really going to be much there. You're always going to kind of be adding stuff inside the wrapper function. Any last questions about this? Because otherwise we'll wrap up, take a break, and get ready for the assignment 3 stuff. So Matthew, the decorator repeat encapsulates the function argument so that the wrapper can use it, and that it is separate for each decorator call. The decorator repeat encapsulates the function argument so that the wrapper can use it, and that is separate for each function call. Just get my head around you. So the question here, the decorator repeat, encapsulates the function, yes, argument so that the wrapper can use it, yes, and that it is separate for each decorator call. Oh, sorry, I understand what you're saying. Right, so you are... Yeah, right. I mean, so this is... that's interesting. I think that the bigger thing for me I really want to re-emphasize again, which I did at the start, is that this decorator... I mentioned at the start that this decorator is not called at like the actual running or call of the function. And this is a very important concept because, as I said, it's what varies compared to like the decorator for example I showed you before. This kind of like, primitive decorator approach is where your functions, as we said before, are being like decorated when they're called. You're wrapping it at call time. With this, if you remember when I commented out the main before, you can actually see that the decorator is still running twice, right? They're still running twice, and that's happening regardless of whether you call it or not. So it's actually modifying the function. So what it means is that your ability to call getLastName in its raw form does not exist anymore in this program, right? You can't actually call getLastName because when you call getLastName, now, even though it has the same name, you're actually calling the wrapper that's kind of quietly wrapped around it by the decorator. So just remember that decorators apply their decorating at the runtime. Now, not the runtime, like at the load time when your code's being loaded in whilst it's running. Does that mean that everything that a decorator can do has to happen when your code, before your code actually runs? No, not really, because your decorator returns a function. So what I mean by that is if I put another print here, like hello, the first print will run when the code loads because the decorators are applied on the code loading. But because they return a function, these new wrapper functions are now ready to go, waiting to be called. So that actual internal hello is called when they're run. Sorry. What have we done wrong here? But it expects a fruit. Like that. Ugh, fruit's not defined. Stupid program, I hate it. So those hellos are actually called, when the code is called, when the function is called, not during like the loading of the program. The last question I'll answer before the break, will it be a requirement to implement decorators for authorization? No. So as part of your, iterations, we increasingly ask you to write well-designed code, and the expectation that you write well-designed code also goes up. So, for iteration 3 compared to iteration 2, your tutor will expect a certain level of elegance with your code design. What is that level? Well, we just expect you to be thinking about code, and when they ask you during a project demo, what have you done to make your code well-designed, they're going to expect a good answer. So that's kind of a thing that needs to be tackled. Decorators are just a way to go about that, like not repeating yourself, trying to write things top down, a bunch of other stuff we talked about last week from, doc strings to map, filter. These are all different ways you can make your code cleaner, and this is just another way to do that. The reason I pointed out authorization is not because you have to do it, it's because it's pretty much like it's one of the It's one of the most impactful and relevant ways you can meaningfully use decorators that also will just happen to clean up your code a lot. So, you know, wins all around. We got tons of examples about decorators here. In fact, some of this is also useful for your project and whatnot. So go take a look at this if you want to go like back and look at stuff, because we did go through a few different tangents here, but most of it's still the same. If you could leave feedback for this lecture, that would be really good. And we'll take a 5-6 minute break till like 10, 12, 10, 13 a.m. Sydney time, and get back into it.